Hey everyone, we're going to go ahead and get started at this point, and anyone who is late will just need to catch the first part of the webinar in the recording. So thank you all for taking the time to join us today. Our speaker today is going to be Leo, who will introduce himself in a moment. And we're really excited to show you Elemeta today, which is an open source that we put out just a few weeks ago around Metafeature extraction for unstructured data. And with that, I'm going to hand off to Leo, who will take you through Elemeta, the package, the repo, and show you exactly how it can be used.
So thank you, Moran, for the great introduction. Yes, I will talk about a few of the ML problems that we have today, and I talk about how Elemeta can solve some of those problems. So I begin by introducing myself. My name is Leo Dorchli. I am a machine learning engineer in Superwise. I am developing the monitoring capabilities of Superwise. I'm also the main contributor of Elemeta. And the fun fact about me is that I don't really like coffee. I prefer tea, but also not every tea. I'm pretty picky about it. I prefer tea that is more specialty tea, like the one that have to age for many years and all this kind of specialty tea. So that's about me. So I will talk about how and what Superwise doing, and this will help us understand how we came to this realization and why we made the Elemeta. So Superwise is a machine learning monitoring platform. We're helping ML teams to monitor their models in the production systems. We are calculating metrics like data quality, data drift, and many performance metrics. So let's begin. So let's talk about how the models about the advancement of models over the years. So machine learning models existing for a very long time, and then we can see that on the recent years there is a huge acceleration of their development. They were able to solve problems and make products that we cannot do only a few years ago, like self-driving car, like personal assistants, and generative AI, and so on. But what is the problem with that? Is that as the model got more advanced, they also got more complicated and harder to and less explainable. Well, what does it mean? If we will take, for example, a decision tree, it is very easy to understand how it works because we have nodes and we can see which features which features the model is using and what exactly it's doing and how it's working. When we're taking a look on a neural network, there are many weights and many numbers that not really make sense to us and we cannot understand. So there are tools for like Sharp and also other tools for neural network that can help get a little bit explainability, but let's say for example, Sharp it's work much better on models like a decision tree, and that's make it very easy to understand. So why explainability is important for us? So first of all, to use our models, to start using our models in more places, we have to trust them, because for now it doesn't matter how the model is good if we cannot trust it. Because for example, let's say we have a model that have the ability to give to get a loan request, and then decide if it should approve it or it should decline it. And then it is able to tell with a very good accuracy if they're going to return the loan or not. But then if someone will get disapprove, then he will ask why your model disapproved me, and we cannot tell him yes because you did X, Y, Z, and we want something else, so we cannot approve you. If we cannot tell him why we rejected the loan, it is a problem and we cannot use it. Also, we want to detect, we want to know if our models are biased, because it is because in many critical cases it's very important, because it may harm people. And we also want to be able to do what if analysis, which mean let's say let's take the previous example. Someone got rejected from getting a loan, and then he will ask us, okay, so what can I do to make you approve my loan? And then we want to be able to tell him, yes, you have to spend less money, or you have to get a better salary. And if we cannot do that, it is a problem. And the last point is we want to, it is also a summary of the previous point. We want to able to understand if there is unexpected behavior in our models, to make sure that we can use it. So we have additional problem. Our data is getting more complicated, because in the past we use more structured data like CSV and tables, but today our data is becoming more unstructured. We start using more images and text, voice, and so on. And the problem is that it's much harder to work with unstructured data rather than structured data, because, for example, if we will take a table, it is very easy to choose a column, and then there are many tools we can use, like pandas or something like that. We can plot a distribution, and we can understand if maybe we have a minority of Chinese women, and if we have a minority of Chinese women, it may affect our model performance. And also we can detect very easily. We can choose let's look on a segment of Chinese women, and then see maybe the data we have is biased. And those things are very hard to do when we have text and image and other unstructured data. And same about weak spot, because we want to be able, if we want to be able to know if there is subgroup in our population that our model have a very bad performance on them. And it is, as I said before, it's much harder to do it in unstructured data. And also to do a data drift, it's much harder to do it, because there are less features to be compared when we compare it to structured data. So this is why we made Elemeta. So we at Superwise, we realized that many of our customers deal with those problems, and we decided to build a tool that will help them to solve those problems. But then we realized why only give it to our customers? Let's make it open source, so everybody will be able to benefit it and also maybe contribute to it. So let me tell you what Elemeta is. So Elemeta is a Metafeature extractor for unstructured data. What does it mean? It's able to extract features like, so it's currently only support text. It's able to extract simple features like what the length of a text or the amount of words in the text, and also complicated features like what the text complexity, what the language of the text, what the sentiment of the text. So let me give you a demo. This is a demo that's made by one of my co-workers. We deployed a code to Hugging Faces, and as we can see here we have a text box. Let's add a hashtag happy and mention my name. Okay, so we can see Elemeta detected that there is one emoji, and it gave a text complexity score. It's also detected that there is one hashtag and one mention. Mention is this kind of text, and also a positive sentiment and very long list of meta features. Okay, so let's talk about why it's useful for us, how we can use it. So first of all, it can be used for EDA, exploratory data analysis. And that means even before we start developing our models, we can and we want to start to do some analytics to see if there is correlation between features, or maybe detect, as we talked about before, if we have a biased data, if we have a minority of peoples that we want to be aware of. So this also connected to the modeling use case, because maybe after we extracted all of those features and we find maybe a correlation between the features, maybe now we can develop a simpler model, not a neural network that can use those meta features, and even maybe we can add also domain expert meta features. So the model will get those meta features as an input, and then try to give a prediction. So it probably cannot solve every problem, but we can try to do it, and some simpler problem are for sure can be used in that way. But if not, we can also, if a simple model like a decision tree cannot solve it, and we have to use a complicated model, so we can take those meta features and give it as an extra metadata to the data, to the data like text and image, and maybe it will help to the complicated model to give better predictions. And the last use case is monitoring. I will talk about it in a minute, but we can send our meta features to our monitoring system and then to monitor them better. So I will give a deeper dive to Elemeta. Okay. So first of all, Elemeta is we deploy it to PyPI, so everybody can install it via pip. So we can use Elemeta. We can use Elemeta meta features just as a simple function, and without using all of the other features of Elemeta. We can, in this example, we can take a sentiment polarity feature, and also and only import it, and now we can use it using importing and then start using it. We giving the sentiment polarity Metafeature extractor, giving a score between -1 to 1, when -1 is a very negative polarity, very negative sentiment, and 1 is a very positive sentiment. So we can see I love supervised getting positive sentiment, I hate haters get a negative sentiment, and this is not super happy excited sentence, get a pretty negative sentiment score. Also, here is example of detect language. This Metafeature able to take a text and detect and try to detect what the language in the text. Here detect English, Hebrew, French, and Chinese. Okay, so we can use every Metafeature as a standalone function and put it in our project, but also Elemeta supply us an enrichment suite. And what does it mean? We can, using the Metafeature extractor runner, we can supply it the list of the Metafeatures we want to run. Now, using our runner, we can supply it a text, and the runner will give us enrichment, will give us an enrichment of all of the Metafeatures we selected. If we don't select any Metafeatures, if we do not supply, any Metafeatures, what we will get is a default set of Metafeatures, which contain all of the Metafeatures except the heavy compute ones. If we want to get also the heavy compute ones, we can use the compute intensive flag, and then we will get all of the Metafeatures like the sentiment, like the profanity word, in addition to all of the simple Metafeatures. So yeah, Elemeta have a big set of Metafeatures, but it's very easy to also add our own Metafeatures that will fit to our needs. So we can use the Metafeature extractor called regex match count, and here we use regex match count to we supply what is the name of this Metafeature, and we supply what the regex we would like to run. And this Metafeature will find the amount of times that there is the word good in our text. So we initiating this Metafeature, we adding it to the existing metadata runner, Metafeature extract runner, and then we're using again the run function, and as we can see, it detected that there is only one, the word good appears only once. In addition to that, we also able to implement an abstract class, and then implement whatever we want. In this example, I chose to implement is palindrome extractor, which means it will get text and it give us a Boolean value. Is it a palindrome or not? So I created the class, initiating it, adding it to our existing Metafeature runner, and again run the run function, and we can see that the text we gave is not a palindrome. Okay, so we, in all of those examples, we use text, but most of the time we don't work with one text. We work with many texts, and most of the time also with data frames. So we also have a run function that can get a data frame. So here I took a a data set that we have in Elemeta. This data set have tweets, and we supply it with the data set and the text column in the data set, and we call the run on data frame function. And what it's giving us the original data set, the original data frame, and it adding all of the meta features for each of the rows in the data frame as a new column. Okay, so let's return to the presentation. Okay, so this is a summary of what we saw. We can give it a text, we can give it a pandas data frame, and we are able to use every meta feature as a standalone function. And if we want to run many meta feature extractors on the same time, we are able to use the meta feature runner and extract them at the same time. And we getting a key value. If we're using a text, we're getting a key value response, and if we're using a data frame, it will give us a new data frame with the meta features as a columns. Okay, so now let's talk about how we can use Elemeta to monitor our models. So we have a spoiler. So we have our unstructured data models, and we can use Elemeta to start enriching them. And after it enriched the data, it's sending it to our monitoring system. In the demo I'm going to show, I will show you how you can do it with supervised. But Elemeta will work with any monitoring system. If you have a local monitoring system or using any different monitoring system, I'm sure there is no problem to do it in there as well. Okay. So first of all, I'm installing again Elemeta, and I'm installing the supervised SDK. After I install them, I have to do a few imports. And in this demo, we will simulate a use case of someone that getting a data set of tweets, and he want to make a model that will try to predict what will be the number of likes this tweet will get. So I started by using the tweet data frame that we have in the Elemeta library, and it's look like this. We have a daytime column, which means when the tweet is tweeted. I have the content of the tweet and the number of likes this tweet got. So we will begin in this demo. What I'm doing is that I'm splitting the data to train, and I called the second part not test. I called it inference, because we will use the test, and in this case inference, to be to simulate the production data that our model is getting, and supervised will help us to monitor it. So here I am splitting the data, and we begin to connect to supervised right now. So we have to supply our keys to the SDK. So here we supply the keys. Now we have a boilerplate that we have to do only once in the first time of creating a project, viral tweets, and after we created the project, we want to create a model inside this project. And okay, so after we did that, we start train our model. So I chose a very simple model of TF-IDF, TF-IDF transformer. So here I supply it with our train set and also a Y set and test set, and this model is training, and we're getting a model. And after we finish developing our model, we can use Elemeta, use the Metafeature extractor to start extracting the meta features. So we now enrich our original data set with additional meta features. So as we can see, now we're getting a score in addition to the previous columns. Now we have a emoji count, text complexity, and many other meta features that we can use. And after we did that, we sending our training set to supervise. And this called to create a data set. So we're sending our enriched data set to supervise. After we did that, let's take a look what we will see in the supervise UI. Now we will be able to see this interface. So here we have all of the distributions of our features, like the text length that extracted by Elemeta, the word count, and also supervised calculated for us the feature importance of each feature. So it seems like there is a big importance for our model on how long the text is. And many other meta features. So we have here the distribution of languages. We can see that there is mostly Hebrew tweets. Mostly English tweets. And okay, so let's continue. So now we will start simulating a production flow. So now it will this box will simulating a production data that coming every day, and the model have to give a prediction on how good on how many tweets this how many likes this tweet will get. So until here, this is the data generation, and from here the only line we have to add is to make enrichment on the outgoing predictions that our model makes. So here we're sending the data to supervise, we're sending the chunk to supervise, and after we send the chunk to supervise, we will be able to see those graphs. Now we'll be able to see the quantity. Let's choose let's see the predicted number of likes. What else can be interesting? Let's see the mention count, text length, text complexity. Okay. So here we can see that I created a two segments of no emojis and has emojis. So you can see that most of the tweets don't have emojis, and we can see that on tweets that have emojis there are more mentions. So maybe there is a correlation there. And we can see that so there is a little bit. I'm not sure we can say it, but maybe no, I cannot really say it. But so we get all of those graphs, and we can make many assumptions and create and we can create, give me a second. Yeah, so we also have an entropy score and many metrics that I will not going to talk a lot about. You can see it by yourself in the UI. So after we did that, we also let's say after we gave the prediction, we are able to know what are the ground truth value for our predictions. So we can also send them, and after we send them, our supervisor will be able to tell us what is the accuracy of our model, and maybe give it a recall, F1 score, many Metafeatures, and also detect data drift, and tell us if it's that there is difference between our production data and our training set, and give us alert when it detects a problem, when it see a big drop in the performance, or it sees big data drifts or reduction in the data quality. So let's talk about a company that you supervise, and how it's helped them to realize that they have a problem, and what the problem is. So here there is a company that have a chatbot, and in the end of the discussion with the chatbot, there is pop-up that asks them to give a score on how good was the conversation. So they realize someday they have a very big drop on the positive feedback. They was not sure why. After they made a little bit research, they realized that also the length of the response was much shorter, which was strange, because there is a correlation in the dates. And after doing more investigation, they saw that when they look on the language the language extraction Metafeature, they realize that after the day of the drop, they saw a different distribution of languages. They saw that there are much more Hebrew text in their data. Then they realized that yes, in those days they opened a new market in Israel. So now there are much more Hebrew talking users that trying to talk in Hebrew with the chatbot, and the chatbot was not so good with Hebrew. So let's talk about roadmap. So we are currently working on doing integration with LangChain and many LLM libraries. We also working on doing more Metafeature extractors for LLMs, and also doing additional Metafeatures for NLP, image and audio, and do some performance optimization. So let's talk what we're doing from here. So you can go to the repo and give us a star if you feel like it can be useful for you. You can also contribute more Metafeatures and share Metafeatures that you used in your company in the library, and you can find a very good documentation on how to use Elemeta and all of the Metafeatures Elemeta have in the documentation. So thank you.
And with that, we are going to wrap, and I'm going to give you a whole 8 minutes back that you originally didn't plan on having. So we will send out tomorrow the recording of the webinar along with all of the assets that we covered here. So notebooks, links directed, the repo, documentation, and so forth. And you will also have access to the supervised community edition. Feel free to use it just to get a feel of how Elemeta can be connected to a monitoring. Within the community edition, you're going to get 3 models for free with no limitations. Or if you have a different monitoring solution that you work with and you want to play around with that, feel free to take Elemeta and to connect it to your existing solution. So with that, we hope to see you all star the repo and give us a lot of feedback so that we can better improve on what we're doing. And, looking forward to continuing this roadmap and seeing what you all contribute. So thank you all. And with that, we're going to stop.